So here is question 6. To find the Fourier series of the function f of x defined piecewisely in 3 intervals from minus pi to 0, pi minus 1, at x equals to 0 is 0, and from 0 to pi is 1. And then to use our solution to find the value of this series here. So even before we start solving here, we know that this second condition doesn't help us to solve because the function is 0. The change there will be 0, so there's no need of us carrying out integration at that point. So therefore, we'll split into 2 parts. So by definition, so question 6, we know that f of x is given by a0 over 2 plus summation n from 1 to infinity an cos nx plus bn sin nx. So let's find. So remember, the one thing that you need to remember that the period of the function is pi minus pi, so it is 2 pi. So therefore, a0 would be 1 over pi integral from, so we have from minus pi to 0, the function is minus 1, and then plus integral from 0 to pi is given by 1 dx. So this will give us minus x, so 1 over pi here, 1 over pi minus x, 0 minus pi 0. So this will give us 1 over pi. Let's do step by step. Minus pi, and then plus 1 over pi x from 0 to pi. So the upper limit will be 0, lower limit will be positive 1. So we have 1 over positive pi times pi plus so let's just put in the limits. So 1 over pi into 0 minus, so pi. Because now it will be minus pi, so positive pi. So this upper limit is 0, so that's, and then plus 1 over pi into pi minus 0. So that we have 1 over pi times minus pi plus 1 over pi times pi. So this will be minus 1 plus 1, which is 0. So therefore, a0 is 0. And then an will be 1 over pi integral from minus pi to 0 of minus 1 times cosine of nx dx plus 0 to pi of 1 times cosine of nx dx. And when we differentiate cosine, we get sine. So this is the same as 1 over pi here. 1 over pi into minus sine nx over n minus pi to 0 plus sine nx over n 0 to pi. So sine of 0 is 0, and then sine of 180 degrees and their multiples is still 0. So therefore, this part will give us 0. Similarly, this part will also give us 0. So therefore, this just be 0. And then Bn will be 1 over pi integral from minus pi to 0 of minus 1 sine nx dx, and then plus 1 over pi 0 to pi 1 sine nx dx. So similarly, we do the integration here. So we have 1 over pi. Integration of sine is minus cosine. So we have, so minus minus will be plus cosine nx over n minus pi to 0. And then this will be minus minus cosine nx over n 0 to pi. So when you put 0, you get to 1. So 1 over n cosine of minus 180 is minus 1. And when you say cosine of so you have cosine of multiples of minus 180. So they rotate around 1 and minus 1. So this will be 1 over pi into upper limit is 1 over n minus this other one will be minus 1 over n over n. And then minus cosine, the same thing. So we have minus 1 power n over n, and then minus just 1 over n. So this will be Bn equals to 1 over pi into 1 over n minus 1 power n over n minus 1 power n over n plus 1 over n. So Bn will be 1 over pi into, so this will be 2 over n, and then minus twice minus 1 power n over n. So it can be written as 1 over pi n into 2 minus 2 into minus 1 power n. Now, this when n, so minus 1 power n is 1 when n is even, and minus 1 when n is odd. So this part, when n is even, will get 1, so will give us a 0 value. And when n is odd, we get minus 1. So minus 1 times minus 2 positive 2, so we get 4. So therefore, Bn has two values, 4 pi n when n is odd number, and 0 when n is even number. So therefore now, putting into the formula, we have f of x is given by a0 is 0, so you don't have to include it. So summation n from 1 to infinity, an was also 0, so bn is what is only required. 4 pi n sine nx where n is odd number. So hence, this can write it as 4 over pi summation n from 1 to infinity of sine nx over n. N is odd number. So that f of x is 4 over pi into, so first odd number is 1, so sine x, second one is 3, sine 3x over 3, next one is 5, sine 5x over 5, next one is 7, sine 7x over 7 plus other terms. So this is the Fourier series of that function. Now we were to compute 1 minus 1 over 3 plus 1 over 5 minus 1 over 7 plus 1 over 9. So alternating. So we have to evaluate 1 minus 1 over 3 plus 1 over 5 minus 1 over 7 plus 1 over 9 minus etc. So we ask ourselves, this is trigonometric part is what helps us to get the answer. When is sine x equals to 1? And then all of us know that the answer is when x equals to pi over 2. So replace pi over 2, let me call this one star, this solution star, to get f of pi over 2 equals to 4 over pi, so the first will be 1, and then sine 3 times 90, then sine of that answer is negative 1. So we get negative 1 over 3. Next one will get positive 1 over 5. Next one will get minus 1 over 7. Next one plus 1 over 9, minus 1 over 11, plus etc. And then here you have to be very careful. You go back to the definition of the function and define f of pi over 2. So pi over 2 lies between 0 and pi. So if you were to draw a number line, 0, pi over 2, pi, and then say minus pi over 2, and then minus pi. So pi over 2 is a value between 0 and pi. So 0 and pi, the value of the function is 1. So therefore, f of pi over 2 is the same as 1. So that is what we replace into the formula that we have. So 1 equals to 4 over pi into 1 minus a third plus 1 over 5 minus 1 over 7 plus 1 over 9 minus 1 over 11 plus other terms. So which tells us that when you make this on the subject, we get the answer as we just multiply by the reciprocal of this. So that becomes the solution. So that is how we solve that problem. So this was the answer to that given series, the last part. Thank you.